In this video, we're going to be looking at the turning points, domain and range, maximum and minimum values, and the axis of symmetries of parabolic equations. So before you start determining domain, range, and all that, you need to know which form of the parabola is given. We have three forms of the parabola in total, and here we just given one of them. By just looking at the equation, you should know which form you have. Here I have what we call the turning point form. I'll show you the general formula. The general formula of the turning point form is f of x equals to a, then open bracket, x plus p, then squared, then plus q. So when you see your graph being in this form, you know that is the what is the turning point form, TP form. So basically what I mean here is this. You can easily get your turning point in this if your graph is already written in this form. No need for calculations. We are just going to extract the turning point, and I'll show you how. So in order to align this graph to that one, I see f of x equals to a. If there's nothing here, it means there's 1. It means your a is positive 1, basically, right? Then that is aligned to that. Then that is aligned to that. And then the squares are also aligned. Then the negative 1 is aligned to q. Okay. Perfect. Now, guys, this is how you're going to get your turning point. The turning point is easy if it's in the turning point form. This value here and this value here gives you the coordinates of the turning point. This inside value being the x coordinate, the outside being the y coordinate. Sure. But there are two rules that we need to know. The first one is this. Whatever is inside, which is your x, will be the opposite when it comes to the point. That is the first rule. So if you have -4, it means here you must have +4. And then this one, the outside, which is your q, basically is going to be exactly the same. The outside does not change, but the inside value must change all the time. It must change all the time. So if it was +4, you write -4. Don't forget the sign is always going to switch, right? Perfect. Now that we have our turning point, we can get two things from it. We can get two things from it. But before we do that, I want us to discuss this. So let's look at the value of a. A is +1, right? A equals to 1, which is positive. So a is basically greater than 0, right? If a is greater than 0, it means your graph is basically facing upwards. Your parabola, it's something like this. So a always tells you the shape. If it's negative, it means your graph is facing down. Perfect. And then here on the turning point, we have, sorry. So the turning point is 4 and -1. Right. Perfect. So let's check what does 4 do. 4 basically cuts the graph into 2 equal parts. You see this part, this side will be the same as that side, this x value here, which is 4, right? So 4, we call it the axis of symmetry. The axis of symmetry, because it divides the graph into 2 equal parts. So if the question asks you for the axis of symmetry and the graph is a parabola, you know that they are actually asking you the x value in the turning point. The x value in the turning point is the axis of symmetry. Don't forget that. For a parabola, the axis of symmetry, the x value in the turning point. Okay, perfect. And then now let's look at the y on the turning point, right? So the y just tells us if the value is a minimum or a maximum of the entire graph, right? So y comes here, basically. It comes this way, the y. So it's here. right? And then, so here y is equals to -1, basically. And then from here, we're going up, right? Which means this y value here is the smallest because all these y values that follows after it are bigger. The y values that follows after this one are bigger. So this is smaller, is the smallest, right? Smallest, né? Sharp. So if it is the smallest y value, we are going to have basically a minimum value. Né? Remember, we said y equals to -1 is the smallest, so is the minimum value. So it's the smallest possible value that the graph can go into. Right. Perfect. And always, ladies and gents, if your graph is facing up, you are always going to have minimum value. Né? If your graph is facing up, minimum value all the time. If the graph is facing down, you have maximum value all the time. Okay, perfect. Now, let's go and talk about the domain and the range, right? Let's start with the domain, which is the easiest. The domain, ladies and gents, right, is just asking you if you have restriction on the inputs. Né? On the inputs. Do you have any restriction on the inputs or the x values? Ne? So domain refers to the inputs, which are the x values, right? So the question that I'm going to ask myself is this as I do the domain. Ne? The domain is here, remember, on the x, right? Is there any x value that when I put here, this function is not going to exist? Is there any x value that when you put here, the function is not going to exist? And the answer to that is no, right? Whatever x value you put here, your function is always going to have an answer or an output. So it means the graph is existing for all x values. Né? It exists for all x values. So you're going to say x elements of real numbers. So you are basically saying our domain is going to exist as long as the x value is a real number, then the domain exists. And always your domain for the parabola is x elements real, right? The only functions, ladies and gents, I'm giving you this tip is very important. You have to know it and write it somewhere. The only functions which their domain are going to have restrictions is those ones where the x is under the fraction. If you have a fraction or your x is under the fraction, I mean your x is the denominator on the fraction, then you are going to have to do restrictions. But otherwise, always your domain is x elements real, as long as you don't have a fraction, right? So the best way to determine domain is to ask yourself, do I have a fraction or not? If you don't have a fraction, you just write x elements real. If you have a fraction, you have to look for the x values where there are restrictions, and we're going to discuss that later. But for now, you look if there's a fraction or not. No fraction, x elements real. Okay, that's it. And then now let's go to range. So the range refers to the output, né? Refers to the y values basically. So range is easy, ladies and gents, as well. For the parabola, you always check if you have a minimum or a maximum value. Né? So in this case, we have a minimum value, right? Which means -1 is the smallest y value. The other y values are going to be bigger than -1, right? So you are basically going to say the y values on this function are going to be bigger than or equals to -1. Why? Because -1 is your smallest value, which means all these y values that follows after -1 are going to be bigger than -1, right? And ladies and gents, we have discussed everything that I said we're going to discuss. Now let's go to the second question and discuss all this again. Repetition is important, but I advise you to pause the video and try on your own first and then resume. Okay, let's go. The second one. Okay, remember I said when you start you check the form that you are given in, right? In this case, we're not given the turning point form. Ne? Here we're given the basic form. The basic form, general formula, it's f of x equals to a x squared, right, plus bx plus c. And, okay, here, remember, if there's nothing, it means it's 1. So your a is -1, your b is +2, your c is 3. Right. Perfect. Remember, before you find any other thing, before you find domain, range, maximum, minimum, and axis of symmetry, right? You need to find the turning point. Né? You need to find the turning point. In the basic form, this is how we're going to find the turning point. This is how we're going to find the turning point. Okay. So the turning point, the x value on the turning point, right? Which we said is the axis of symmetry. So the axis of symmetry is basically given by -b over 2a, né? Which is equals to, I'm going to substitute. There's a negative. What is my b? My b, it's, okay, let me write them down here. So from this basic form, I can see that my a, it's -1. My b is 2. And my c is 3. So my b is 2 in this case, and then over 2, and then my a, I'm going to substitute my a here, which is -1, right? And then I can easily see that, okay, the answer here is 1, basically. If you press this on your calculator, you should get 1, right? Perfect. So now we have the x value on the turning point, or the axis of symmetry. Don't forget, ladies and gents, the x value on the turning point is the axis of symmetry. So we have the axis of symmetry in this case, right? Which is our input, basically. Remember, x is the input, right? Is the input. So always, if I have the input, I can always get the output. Né? So now, this is our function. I have k. Instead of writing x, I write what I'm inputting. I input 1. So this means k input 1. You see where there was x, I replaced this with 1. It just means k input x. It means everywhere this side where there is x, I'm going to put 1. Okay, so I have -1. Where I see x, I put 1. Then there's a square. Then there's +2, 1, +3. This is easy, ladies and gents. You see here there was x. I put 1. I'm just writing everything, basically. And then here there was x. I put 1. And then plus that. And then let's simplify this. This is -1 +2 +3, which is 4, basically. Right. So it means if our input is 1, our output is going to be 4. Therefore, we have now obtained our turning point. So the TP, in this case, it's going to be 1, which is the x, and then 4, which is the y, right? Then if we have our turning point, we know that, okay, this one is our axis of symmetry, right? Is the axis of symmetry. So if they say the equation of the axis of symmetry, just say x equals to 1. Don't just say 1. If the question asks you for the axis of symmetry and you just say, you write your answer as 1, what is 1? You see, you're not going to get a mark. You must always say x equals to 1 to show that you know that it is the x value on the turning point. Okay. Perfect. And then this one will either be our mean or max based on where the graph is facing. Remember, we said a is equals to -1, which is less than 0 now, right? If it's less than 0, we're facing down. So our parabola looks something like this now, okay? So it means our turning point is going to be there. Oh, sorry. So the y value is coming this way, né? So here you have y equals to 4. And you can see that, okay, all the other y values after that one are going to be below it. So they are smaller because you're going down. You see, from 4, you're going down. So which means this is big, is the biggest y value, right? So the y value in the turning point is bigger, right? So if it's bigger, we call it a maximum. Is the maximum value. So this parabola will have a maximum value. Okay. Right. And then now, if it has a maximum value, we can do this. Okay. We can easily do the domain and range now. Domain. Okay. Remember domain, I said we check if the x is under a fraction or not. In this case, we don't have any fraction, right? If we don't have any fraction, if I can show you here, no fraction, you see? So if there's no fraction, it's always x elements of real. Then that's it. And then your range. Okay, your range. You check, okay? I have the maximum value. This y values here, they are going to be smaller than. They are going to be smaller than the maximum value. So your range will be y, it's smaller or equals to the maximum value, which is 4. Right. So you ask yourself, how will these y values relate to this one? They are smaller than. So you just say y it's smaller than or equals to 4. And that's your range. And you should be fine, ladies and gents. Okay, let's go to the next one. I'm going to move fast now because we've already familiarized ourselves with this. So TP, in this case, I suggest you pause the video and try and then look at the solution. So the TP is going to be 4 and 1 and -1, I mean. Then here my A is 1, right? So which means my domain will be XER because there's no fraction. And then if I see A is equals to 1, which is greater than 0, so I'm facing up. So if I'm facing up, I have, this will be, remember, I have a minimum, right? This is a minimum value, right? This is the axis of symmetry. Don't forget the x value on the turning point, the axis of symmetry. So if I have a minimum value, it means the range is going to be y, it's bigger than the minimum value. Remember, if you have the minimum, it means this is the smallest, right? So y must be bigger than the smallest. So we found domain, range, turning point, axis of symmetry. Yeah, we found everything in this one, basically, right? Yeah, that's fine. Okay, now we're going to go to number 4, which I'm going to move fast as well. So here we have 1, basically, so it's -1. So our A, it's -1, which is less than 0. It means my graph is facing down like this, right? If the graph is facing down, it means I have, okay, this is going to be max, right? The highest y value because all these are going down, right? So let's do my TP quickly. So my TP is going to be 5 and 4. Remember the inside switches, the outside remains the same, right? And then this is going to be the max because A is negative. So we're facing down. This is axis of symmetry, right? The equation of axis of symmetry, it's x equals to 5. And then we now gonna find the domain and the range, right? So domain, remember I said you check if there's a fraction, there's no fraction, so your domain is XER. Then your range, for the parabola, you say y, and then if you have a maximum, if this y is there, remember y, you know you're gonna use this, right? The 4. So 4 is the biggest value, right? Because we said maximum. So it means 4 must be biggest then. So is the big. So 4 is bigger than or equals to y. So y is basically less than or equals to 4. You see how we do it? Perfect. And then we're done with this one. Now we're going to go to the next question, right? Okay, let me get my color. Okay, perfect. So here, I know that I have a basic form. My A is going to be 1. My B is going to be -6. And then my C is going to be 9, right? And then I'm basically going to use this. Remember, x equals to -b over 2a if I have the standard or the basic form, right? So which is -6 over 2, and then my a is 1, right? Which is 6 over 2, which is 3. Remember, we said this is going to be your what? Your input. Ne? So it means h input 3. So where there was x, I'm going to put 3, basically. Everywhere where there was x, I'm going to put 3. So I have 1. Where there's x, I put 3. Squared minus 6. There's 3 there, then plus 9. Do you see it? I just rewrote this. But this part here replaced by 3. And this part here replaced by 3. That's how you substitute. So this means h input. So when it's like this, it means h input x, right? X can be anything. In this case, our x is 3. So where there's x, I'm inputting 3. And then let's see what our output is. So here I have 9 minus 18 plus 9, right? Which is 0. Right. Which means our turning point is on 3 and 0. This is your TP, right? Then now let's check. This is the axis of symmetry. Axis of symmetry, which is x equals to 3. Let's check. Will this one will be a minimum value? Agree? Mean value of y equals to 0. Why? How did I see if it's a minimum? We look at a, remember. A positive. So a equals to 1, which is bigger than 0, right? Which means I have this here. I'm facing up, right? I'm facing up. And if I'm facing up, I have the minimum value. Do you get it? Because this y value here, y equals to 0, will be the smallest. I'm going up. Domain will be xer because there's no fraction. Then the range, let's see the range. The range, I'm sure you should have noticed now that we're going to have this, right? I have y, and then I always use the y value in the turning point. Is the y value in the turning point the biggest or smallest? Is the smallest. So the y value in the turning point must be smaller. So 0 must be smaller than or equals to y, which means y must be bigger than or equals to 0. Does that make sense? Perfect. And then that's your range. Okay, let's do the last one. Okay, this one, ladies and gents, this one. Okay, sharp. So here we're given it in the turning point form, but we firstly need to remove this square brackets first, right? Remember here, there's an invisible one. So the outside -2 will multiply that invincible one and that one. So your actual m of x in the turning point form is -2 because 1 times 2 is negative. I mean, 1 times -2 is -2. Then when I have x plus 3 squared and then plus 8. Because -2 times -4 is +8. Then we can all see that our TP is going to be -3 coordinate 8. Remember, the inside changes the sign and the outside does not. Right? And then we're going to have this now. This is the axis of symmetry, which is x equals to -3, right? Axis of symmetry equation is there. Then this will be the max value How did I see that is the max value? Remember, A is negative, which is less than 0. So we're facing down. You see? So you're facing down. So your y value will be here. Y equals to 8 will be the highest because you're going down. Right? Perfect. Now we can do domain. We can see that domain is XER because there's no function, there's no fraction. So that's your domain. Right? There's no fraction here. Sharp. And then now let's do the range. Right. Range always let me show you a strategy. You always just say y, then write the y on the turning point. Right. And then is this the biggest or the smallest? Is the biggest. So it must be the biggest like that. You see it. So 8 is biggest or equals to that. And then you're done. Ladies and gents, if this video was helpful, please don't forget to share with family and friends and to hit the subscription button for more content like this. Aluta continua. Tango.